Okay, so I just finished installing the pickup and I also put the jack in, but there's a small problem. This part doesn't come out far enough, so I have to sand it down. I couldn't find any sandpaper, so concrete it is. Okay, so desperate times call for desperate measures or something like that. So let's start. Okay, I finished and I was able to install the jack. Alright, so I got the soldering iron heating up and I'm waiting so I can solder these connections. Yep. Okay, so here is the finished product. Let's start with the back. So over here I got the pickup wired straight to the jack. I didn't use any of the potentiometers or tone knobs. And for the front, we got, this is a tuner. I used a bolt and I used two nuts on this side. One holds the string against the head of the bolt, and then the other one works here with the bottom one, and it kind of creates tension and it holds everything in one spot. And here I got the nut. I just use a piece of a broken pencil and I kind of drilled a little divot for it to sit in. I did the same thing for the bridge, and then here's the bridge pin. I use another piece of the pencil and I kind of just drilled a hole and put the end of the string in there. And then the hole is a little bit too big, so then I kind of put in some paper so then it would take up more space, and then I hit the pencil and it started to like splinter, so it helped a little bit more with taking up some space. And yeah, let's plug it in and see how it sounds. Okay, let's turn the amp on and see how it sounds. Feedback to see. So I'm not gonna be able to shred, but okay, at least try to play something. I'm not used to these no frets. Let's change some settings. Yeah. So we got some I'll change the setting. Some physics I can show. I'm gonna go to a clean setting. So first I can show off wave harmonics. This, I believe, is the 12th fret, or what would be 12th fret. So this is around half the string. So then this is where a note will be, and let's see if you can hear a harmonic. Here, maybe I'll change it so it's a little bit louder. If I go a little bit to the either side of it, I'll be hitting the anti-node and it'll make a muffled sound. So did it work? Right here. And there's obviously no nodes, so let's see if we can find some nodes. Too, and yeah, there's also electromagnetism, and I'll be able to explain that on some paper. So yeah. Okay, so I have some of these diagrams on paper to help show you how these physics principles work. So it might be a little bit hard to see, but right here we got wave harmonics. So let's start off with that. So right here we have this big wave. This is what happens when you just pluck the string normally. The string vibrates as one big wave, and it vibrates at a frequency. And this frequency is known as a fundamental frequency because we got a node here, a node here. So it kind of just stays the same. And then over here, we have the 12th fret, which is exactly halfway in the string. So you got equal parts of string here and here. So if you put your finger here and you pluck the string, this will create a frequency that is twice the fundamental frequency, which will create a sound that is 1 octave higher. Now you can keep on doing this. Let's say you go a little bit over here, you can find the third node, and this will create a frequency that is 3 times higher than the fundamental frequency, which then creates something known as a perfect fifth. And then if you go find a fourth node and then you do another harmonic, that will create a sound that is 4 times the pitch or the frequency of the fundamental frequency, which in turn creates a sound that is 2 octaves higher. Okay, so now let's move on what is electromagnetism / how a guitar pickup works. So right here I have a battery. Doesn't really look like a battery, but let's just say it is. And we have one wire connecting 2 of the terminals. So let's say we connect it and then electrons start flowing, going down this way. This creates a magnetic field on the wire from the electrons flowing through it, and that will kind of look like a circle going around it. So this magnetic field by itself is not very strong, so that's why you have to wrap a pickup a bunch of times. Okay, it's not the best coil, but once you wrap a pickup a bunch of times, all of these magnetic fields add together, so it kind of look like this. And magnetic field is a lot stronger. So you can have a magnet like this, but the way that pickups have it, they have a piece of metal, something like iron in it, something that's like, you know, can be magnetic. So these pieces of metal, they have a bunch of little domains that kind of like north and south, but the thing is they are all like just not lined up, so it kind of just like look like that. So if you get this and then you have the magnetic field induced onto these little domains, it'll cause them to all line up and in turn create a much stronger magnetic field. So when we go up here to our pickup, so then we got the magnetic field, which is kind of coming out like this. Guess we can do a couple more, right? And let's say we got the string going over it. So basically how the pickup works is when you pluck the string starts to kind of vibrate. So, oops, maybe you don't draw it like that. That's kind of the nodes, right? That's not a good way. I don't know why I drew it like that. But you pluck the string, and let's say it looks like that. So if it's going up like this, since the strings are magnetic, this kind of disrupts the magnetic field and it goes up. This will cause the electrons to flow through the pickup going up, so they kind of wind around like this. And then if this string, once it vibrates and it goes this way down, the electrons will go down through here and it'll kind of flow like that. So then this signal goes back to the amplifier, and then the amplifier will amplify it. So yeah, that's how these physics principles work.